So first of all, we would like to start up with a reality check about what service assurance is and the need for it. And to do this, we, NetRounds, did a survey out there in both the enterprise space and the service provider space around what is the impact really of these kind of problems. So, and we got two interesting findings. So first of all, we discovered that about 60% of the faults being worked on by support and faults impacting customers were discovered by the customers themselves. So they were not detected by tools in the network, and the customer basically had a bad experience and they had to raise a trouble ticket to get that problem resolved. And that's of course quite bad because it can result in extra costs for support and escalations, and also churn and brand damage. The other finding is that this of course has a big price tag to it. So the average annual cost for brownout in US enterprise space is around $600,000, and in the service provider space it's several times larger than that, of course. And by that we mean faults that are not detected by the currently deployed tools. So that means that there is definitely room for improvement and money to be saved, and better experience for the customers to be had by working on these issues. So some may argue that automation is something that is coming to the rescue here to fix all of these problems. So let's take a look at what we are doing here in the industry today about automation and how it applies to service assurance. So the focus for automation today is largely around VMs, VNF of course, configuring policies, firewalls, doing routing, etc. And this is all great. This is about taking physical boxes, making them virtual, and automating the configuration for it. But what are we doing around the assurance? We are still collecting counters, trap, ping, and other types of alarms, which is kind of device and infrastructure-centric alarms rather than something that represents the customer experience. So these does not really correlate with the customer's experience if the temperature of a device is hot or cold. So what can be done about this? So something that has been done in the past is the old alchemists. They have been trying to make high-grade metals like gold and silver out of base metals. And this is something that we know already than 2,000 years ago that it doesn't really work because they are fundamentally two different things. So if you try to apply the same logic on what you have available from passive collection in the network today, you have your traps, counters, and ping and syslog, and you try to figure out what is the voice quality in the network based on this. It doesn't really work because they are so different things. They represent different behaviors in the network. So just because that the temperature is okay on the device, it doesn't mean that the customer is really happy. So there must be another way to do this, and that is where active test and assurance comes into the picture. So we have a solution where we actually inject synthetic traffic into the data plane of the customer and actually send the right kind of traffic that represents the service that the customer is buying. And by having a synthetic voice call, for example, we know if voice is actually working. So this is like going for gold directly. You don't need to make something that looks like gold. You actually measure it by having the real type of traffic on the network and draw conclusions based on how it actually performs. So it's, and that we need to do across all the platforms. So it's not just a front haul or back haul issue in the network. It's about measuring across all the relevant domains, all the way from the mobile backhaul to your data centers, to the cloud, or where the services are hosted. And this should also be done for the layer of the service that we are selling. So we're now looking at the toolbox of a few different test tools available, and if you're selling a bit pipe service, you want to test that that bit pipe service is actually fulfilling the needs by doing benchmarks of UDP and TCP performance between two endpoints. If you're selling a IPTV service or over-the-top video service, you want to, of course, make sure that there is no frame drops in your multicast streams or that the HTTP buffering for a unicast video stream is going as it should. For a voice service, of course, you should have a synthetic voice call running, making sure that the voice quality is good end-to-end. And if it's just the internet service that you're providing, it does make sense to check that DNS performance is good, that you get the responses quickly and that is correct the response. You should check page load time. You can do basic speed tests to make sure that you have good bandwidth for internet service, and work with other tools like ping and traceroute to document routing performance. So it's important to pick the tool that is actually matching what the customer is buying so that you're testing the right thing. Because if you're just doing a normal ping to a device, you see that the device is reachable, but it doesn't tell you that the customer service actually works end-to-end. It's two very different things. So how do we do this? Well, the trend here is about moving into distributed computing. So we're putting out more hypervisors out in the network than ever. And this opens up for an extremely nice use case of deploying what we refer to as test agents. In our case, it's deployed as a VNF, so we provide a small VNF that we deploy in all the hypervisors out there, both in the data centers, we put them in the public clouds, and we can put them at customer sites, and even in some cases inside routers and other CP type of devices. What we then tell the test agents to do is to actually generate one kind of traffic from one endpoint to the other one, and then we analyze what is the quality. So this is like going for gold directly. So we look at how does a service perform between our reference endpoints. If this is all good, then it's a very reliable metric of that the customer will also be happy because this is what he is ultimately buying. If you put this into the context of a 5G network, especially where you are putting hypervisors in the edge of the network to spin up mobile VNFs like VCUs and VDUs, then it's trivial to also spin up a small test agent VNF just on the same platform, just next to it, and having it measuring the data plane performance to your data centers. Both using VirtIO and SRIOV, of course, because that is what your mobile VNFs are actually using as data plane. So this gives a real-time view of how the data plane is actually working between these important points in the mobile network. This we're already doing with a couple of customers out there that is deploying distributed compute and virtual RAN. And it turns out to be extremely successful and valuable by having these kind of insights. And when you start doing this, you also need to start including assurance into your automation story. So when you are deploying something out there, if you're deploying a new site, you're deploying a new hypervisor, or just a new VNF, it makes sense to start with always testing that this is correctly deployed. So this is what we refer to as a service activation test. So that can include checking the bandwidth, the basic connectivity, and other things. And basically we get a green light or a red light depending on if the service is working as it should. Now, since we have the infrastructure in place to run test traffic, we can turn down the volume from blasting lots of bandwidth into just sending a small amount of bandwidth, which can be referred to as a quality monitor. So maybe we can send a heartbeat into different QS classes to make sure that the network is continuously available. It doesn't cost much bandwidth, and it provides a huge amount of value by always doing heartbeats in all combinations of the network. And step number 3, things will continue to break because there is always hardware failures and cables being disconnected and fiber cuts and so on. And that's where troubleshooting becomes an important use case for this. So you can use the same infrastructure to also figure out what domains are impacted by a fault. So you can sectionalize where the fault is located and better address your troubleshooting efforts with this. So expanding the space a little bit outside of the 5G domain, we could look at example topology for a service-wide network like this. So one use case is about doing active assurance to the public clouds, because more and more services sits in the public clouds like Google, Amazon, and Microsoft provides. And if these ones are not reachable with good quality, basically the customer will not have a good experience because they are consuming what is available in the cloud. So actively testing that you can reach the cloud makes perfect sense. And this is an extremely easy deployment to implement, actually. For SD-WAN and VPN services, it is actually possible to put active testing equipment inside many of the CPs out there, especially with SD-WAN, where each CP is actually a hypervisor. Then you can spin up a small test agent instance, and test the VPN end-to-end. And in this space, it's extremely valuable because you often tie a VPN service to fines if you don't provide a certain availability and performance. And if you as an operator can pick up that we have a problem with this VPN before the customer identifies it and complains about it, you can actually reduce fines. And yeah, in the best of worlds, the customer will not even notice that there is a problem because you already have fixed it, because you did know about it the second it happened. So this is a quite valuable one when you're selling VPNs. From a customer point of view, they could deploy the same solution. So they could monitor what they are actually buying. So they could put out test agents on all sides, send traffic to the network, and monitor what KPIs they're actually getting. And they can also put up their test agents in the clouds, checking that their cloud connectivity is good. So by doing that, the customer also has external validation of the service they're buying, and they know that it actually works. And when something breaks, their operations will instantly know that there is a problem here. It doesn't matter if it's an overheated device, fiber cut, or outage in an unmanaged network that no one is managing here. Because if the service breaks, they will instantly see that by the test traffic not coming through. So it covers kind of the blind spots, you can say. In a mobile transport and backhaul network, this is something that has been done for quite a while, and it's a classic use case, but it's still worth mentioning it, and that's using reflection measurements. So reflection measurement is basically like a normal ping, but you do it with a protocol designed for one-way latency measurements called TVAMP, for example. So then you know that your mobile backhaul is performing as it should, and you can also go out and identify areas where you have quality issues and address those. So classical mobile use case, we have been doing this for a long time, but it's worth remembering that it shouldn't be forgotten when you move into the virtual world. So going back to mobile a little bit. So network slicing is something that pops up more and more. And by this, we refer to that the network is built to deliver different kinds of services. You build one slice for high throughput, you build one slice for low packet loss, and one for low latency. And they are all built and implemented a bit differently. And inside each slide, it does make sense to send, again, test traffic to make sure that the slice is performing as it should. So if you have a high throughput slice, benchmark the throughput. If you have a low packet loss slice, benchmark the packet loss. And of course, for latency, we benchmark the latency. And to make this a little bit more concrete, I'm going to talk about a use case that we did together with Vodafone around connected cars. So in this example, the latency was what the network was optimized for, because the decision of how the cars should act was done in the cloud. So a consistently low latency was the #1 priority for this service. So what we did is we deployed test agents in the data centers, and we were actually 100 times per second measuring the real-time latency and availability of each device in the network. And by doing that, we could actually provide metrics back to machine learning systems to help them to figure out that we have a problem in this area of the network because we know that the service doesn't work there. It doesn't matter what the reason for the fault is, because then the machine learning system knows that for a fact we have a problem here. And then it can start to correlate with syslogs, device state, and other things that could be impacting it. So we became a really, really valuable input into the machine learning system in classifying something as a false positive or a real event. Because if the Netron's test agent says it's down, it is very likely down because we cannot send packet from point A to B. So this was quite successful and a really interesting use case. And I think we will start seeing more of those, especially as availability and latency becomes critical selling points when pitching these solutions to the end customers. Additionally, besides measuring the end-to-end quality between the device and the core, you can of course put test agents out in the network, so on different sides of the mobile packet core, in different data centers, and keep track of that. And that you do to sectionalize and pinpoint what part of the network is impacting the experience. So that is the reason why you also have them in the middle. So to summarize, what is important to remember when automating your active assurance? So you always need to think about multi-layer and multi-domain capabilities. So service assurance is not just doing one section of the network and then being happy, assuming that the left and right side are all okay. It's about covering the access domain, the backbone domain, and the domain to the cloud or the service provider. So that's the number one important thing to consider. You should also always think about this on scale, because this should be something that is always done. For every change that you do, you should test the change. This we have been doing in the physical days. When you install the box, you typically pinged it. That was a way to make sure that the box was reachable. But we should keep this mentality when moving into the virtual world, and we should start doing this on scale. Because when you automate the deployment of things, you should also automate the testing of it. It makes perfect sense. And when we talk about scale, we need to be able to do this at thousands of devices, or tens of thousands, or even hundreds of thousands of endpoints that should be tested and monitored using these methods. And you should include it in your automation tools. So whatever you're using, Cisco NSO or Terraform or something else to do your orchestration for you, you should, as a last step, when you're done with something, add a check. Does it actually work? Yes or no? Because you know how it should work, so it's easy to test it and validate it if it's working as it should. And to be successful here, you also need to have a lightweight solution, because you don't want to reserve a huge chunk of the hardware for testing purposes or the bandwidth. So it should be a lightweight piece of software you put in, because you obviously cannot put in hardware test systems out there, because once you start talking about tens of thousands of something that is a hardware box, it becomes hugely expensive both to buy and to manage. So these are really the summaries that we would like to highlight, what you should remember from this talk. And we are here at the conference, so we have a booth just outside here. So please come see us if you would like to hear a little bit more about it. And we also we do quite a lot of research on these topics, and we publish white papers, and those are freely accessible from our webpage. So if you want to read the studies and surveys we did about the cost and impact of outages, there is a freshly released white paper available, among many others. So that's everything from me, so I think we are open for questions.
Let's go warm hand first. Any questions from the audience? Gentleman in the front, if you can state your name and your affiliation, it'd be great. Yes, just coming. 3, 2, 1, there you are.
My name is Abdul Munib. I'm from PTCL. My question is that, as you were telling that you need to have at the customer's place to know the actual quality of experience. When we are talking about customer, in case of mobile, it will be mobile. In case of fixed, it can be a DSL modem or a ONT. So, and you are also telling that your solution comes as a part of a VNF. So how can we install VNF on mobile or ONT, because there are proprietary issues?
Right. So depending on your network topology, you will deploy it in different ways in different devices. So in a mobile network, it's quite common to put it in your furthest out edge computing device, so like the virtual RAN devices. But we do not play in the space of installing something on a customer phone. But if you're providing an enterprise service in a mobile network where you control also the CPE endpoint, you could embed the testing functionality into that CPE if you're taking responsibility for that section also.
That side, but in that case, you are taking out a good section for in mobile, the RAN section, and also for the fixed, the copper or the fiber section, which is adding a good, contributing a good portion in the quality. So then you will not have the true quality of the customer, because you will have the quality what at the end, at the last active device as a router or RAN. But what's happening after that, you will not be knowing.
No, you're correct that there always will be a blind spot somewhere because you can only measure between what you can control ultimately. So I mean, there is no perfect solution for all kind of problems, but by starting to take the edge device that you control and take like the cloud, you have an extremely large portion of the end-to-end connectivity. And if that is good, then you know that this section is as good as you can make it.
Thank you.
Any other questions? Okay, well, thank you very much. Thank you, Jonas. Very good. Thank you.